what initially spurred my interest in this area is really two things. The first is that truck driving is one of the most dangerous professions in the United States. I don't think that's necessarily realized that well. It typically ranks in the top 3 year to year. Over a quarter of occupational fatalities occur in road traffic accidents. And since truck driving, the profession is to drive a truck on the road, it's not surprising that they are overrepresented in that. About 10%, truckers account for about 10% of occupational road traffic fatalities. And if you do the calculation, you see that the fatality rate for truck drivers, occupational fatality rate for truck drivers is 7 times the average fatality rate, occupational fatality rate in the United States. So it's certainly a serious problem. The other aspect of this that interested me is that relatively little has been done to study methods of reducing truck driver fatalities as such in crashes. There's been a lot of work on light vehicles, and there have been a number of developments that have reduced light vehicle, passenger car fatalities and injuries. You know, you think of safety belts, you think of airbags, you think of the design of crash structures that basically direct energy away from vehicle occupants. All of those things have been pretty successful in driving down the rate for light vehicles, but there's been relatively little that's been done for truckers. Safety belts are now required to be used by truck drivers, and the belt usage rate has been increasing, and now it's basically approaching, surprisingly, the belt use rate for light vehicles. But beyond belt use, there hasn't been a whole lot done in terms of protecting truck occupants in crashes. For light vehicles, the number of fatalities in light vehicles is down about 30% since 2001. For heavy truck drivers, it's basically unchanged. So presents a real opportunity to do something about that. But while there have been sort of relatively little to protect truck drivers in the event of crashes, there have been a number of technologies that have come along that prevent crash involvement in the first place, various collision avoidance technologies, electronic stability control, forward crash warning, and emergency braking, automatic emergency braking, lane departure warning. Devices like that have come on board, which basically are designed to avoid the crash in the first place. And those are obviously technologies that can reduce truck driver injury in crashes by reducing the crashes in the first place. So that's a good thing. Many of these technologies are already penetrating into the trucking fleet in the U.S. The focus of the current project is to examine what the effect of that deployment of these collision avoidance devices will be on the distribution of heavy truck crashes, and what effect that will have on truck driver fatalities and injuries, and then identify the remaining crash population and simulate that and understand how truck drivers are injured in those crashes, to see what can be done in terms of improving the crash worthiness of the truck and protecting the driver in the event of those crashes. The two primary crash types in which heavy truck drivers are injured and killed are basically one, rollover and frontal collisions. Rollover only occurs in about 4% of heavy truck crashes, yet it accounts for over half of truck driver fatalities and serious injuries. And many of the remaining fatalities and injuries occur in collisions, and primarily in the frontal mode. So those are the two crash types that we've been focusing on, and I've been working with Chiara Silvestri Dolbravoni in this project. Basically, we do the crash analysis to identify crash types that will remain after these collision avoidance technologies are deployed. And Chiara has been simulating what happens to the drivers in rollovers and frontal collisions to see the opportunities, to identify opportunities for optimizing driver restraints, possibly considering airbags, and also to identify the surfaces, the interior surfaces on the vehicle that the driver is contacting in these crash types in order to see if it's possible to make them more forgiving in the event of a collision. So those are the areas that we're working on at the moment. What we are hoping to do going forward is to kind of advance the research in terms of looking at cab crush, because that's an area that we also that also needs to be addressed, and that's part of the and that will essentially emulate what has been going on in the light vehicle population, where the vehicles have been made more crash-worthy by designing in energy-absorbing structures that direct the energy away from, that absorb some of the energy and direct the energy away from the driver. This has the potential not only, I think, to protect truck drivers, but also to protect light vehicle occupants in collisions with trucks by doing a better job of absorbing the energy rather than having it be transmitted into the vehicles. So the net result of this is try to address this problem of basically a static injury risk for heavy truck drivers. The fact that while in general highway safety has been improving, and as I mentioned earlier, there's been a significant reduction in fatalities among light vehicle drivers. What we need to do is do a better job of, number one, avoiding collisions. That's obviously the main event here. But then also, in the event of collisions, protect truck drivers in order to reduce the toll in terms of fatalities and injuries.